Introduction to Electrostatics. So here we have a simulation that allows us to take a look at the atoms and the parts of the atoms that move around when we create what's called a static charge. So we have a sweater, we have a balloon, and this white box here is kind of similar to the whiteboard that Faye uses in the front of class. The thing is, if we were able to look very, very carefully, we would see that sweaters are made up of atoms that have positive parts, called protons, and negative parts, called electrons. And balloons are made up of atoms that have positive parts, called protons, and negative parts, called electrons. And Faye's dry erase board is made up of protons and electrons as well. And currently you see that the sweater, for the most part, has the same number of protons as electrons scattered all over the sweater itself. We call this condition neutral. Neutral is when there's about the same number of electrons as protons throughout a given object. We'll see that the balloon is neutral as well because there's the same number of protons as electrons within the balloon. And the dry erase board, same number of protons as electrons. So all of these things are neutral. Well, I can take this balloon and I can move it, and watch what happens when I bring it to the sweater. I can force some of those electrons to attach themselves or move over to the balloon. If that is the case, we have charged the balloon. You will notice that there are too many electrons right here on the balloon. We call this a negative charge. This is a place in which there are too many electrons for the number of protons. But on the other side, if we take a look at the sweater, we'll see that some of those electrons have been stripped away, and so now there are too many protons rather than electrons. We call this a positive charge. Now if you take a look, the electrons on the balloon, they are staying where we put them. And because they are staying in one place, we use an adjective to say that they stay in one place. We call it static electricity. In other words, the electrons have stayed in one place. In other words, this is a static charge. Now this happens because balloons are made out of a material that is really pretty interesting. You can put electrons on it, but those electrons will not move around once they're on the material that balloons are made out of. So rubber is called an insulator. And that's a material that does not allow electrons to move through it easily. Rubber is a great example of an insulator. Plastic, wood, and glass are great examples of insulators. The other term that we can talk about are materials that allow electrons to move very freely. And if you take a look, my dry erase board here is made out of metal. Guys, watch what happens when I bring this balloon close to the board. Do you see the electrons are moving pretty freely? That's because metals tend to be what are called conductors. They are materials that allow electrons to move around fairly easily. And so as I bring the balloon close, you'll see that the electrons kind of run away and then go back to their proton partners when the balloon leaves. So metals tend to be good conductors. Things like copper, iron, or aluminum. The last aspect we're going to look at is what happens if I quote-unquote let this balloon go. You'll see that there's a very large negative charge here and a very large positive charge here. And when I let the balloon go, wow, the balloon moves. So in other words, is there a force involved? Yes, and we call this an attractive force. And you will see that regions that have lots of negatives will be attracted to regions that have lots of positives. So a negative charge will be attracted to a positive charge. But on the very same idea, if you take a look, I bring this negative charge close to these. Why do these negatives run away? That's because things of similar charges or like charges repel. And so negatives repel other negatives, and positives repel other positives.